Okay, so the session is recorded. We'll post it to our YouTube site. You know, like I said, any questions, email me. Tim's going to take questions at the end. If he can't get to the questions, I'll email him the questions, and I'll let him make a decision whether he wants to blog or send y'all an email or however, you know, we'll figure something out, you know. So, we're sponsored now. We officially have a sponsor, and I'd like to thank our sponsor for you know, sponsoring our chapter, and we'll give some prizes away. Later, I mean, after the session, we'll pick a winner or two, and you'll get an email from me, say you win, and you win a prize. Typically, it's like a gift card or something from PASS. And so thanks, Nutanix, for sponsoring our chapter. So this is a really important code. If you're going to PASS and you use this code, and we get, I think it's 20 people, so use this code, we can give away a free session, and it would be great to give it to one of you guys. Last year we did it. We gave away a free session, and one lucky one members of the Data Architecture chapter got to go absolutely for free. Got this. The session was paid for, and you see what it's worth, $2,100, almost $2,200. So if you use it, thank you, and hopefully we'll be able to give a winner away this year. PASS has a Passion Award, and if you know somebody that does a lot for PASS, you know, that gives, you know, volunteers, please nominate them. And you can, there's the link right there, Passion Award at SQLpass.org. You know, it's just an honor to be nominated. Okay. And the deadline is September 1st. So I just saw that, but there you go. So with that, I'm going to change it over to Tim. Tim, can you hear me okay?
I can.
Great. And so Tim has come to join us, and I'm switching the control over to Tim now.
All right, so Rob, you should be seeing the data architecture initial slide here.
I do. I see it. Thank you.
All right, so thank you all for giving of your time this Wednesday afternoon to further your education. This topic is understanding SQL backups and restores. This session kind of came to be when I was managing a group of DBAs, and I started asking questions of how many of you have ever restored a database and with no recovery and additional transaction logs, or a differential transaction logs. I've done a point in time, recovered the master database, just some general questions. And when I found out that some had only restored full databases, they really didn't have the experience of recovering a full instance and the various types of backups and so forth, I decided to put together a little lunch and learn, and then that turned into a user group session, turned into a SQL Saturday session, then turned into a book. So the session's kind of grown. I'll try to keep it down to the 60 minutes. I can take this all the way out to 90 minutes or so. So with that, we'll go ahead and get started. And let me get my pointer going. So I am with SQL Skills. We're a team of world-renowned SQL Server experts. I kind of like to say that my team is, and then there's me. So I get to work with Paul Randall, Kimberly Tripp, Glenn Berry, Aaron Stellato, Jonathan Hyas, an incredible team. And we do instructor-led training known as our immersion events. We have those coming up 2 more times in the US, and then I believe Paul's published part of our 2017 schedule. We do online training through Pluralsight, consulting side, health checks, hardware, performance, and tuning upgrades, and so forth. We also do remote DBA, where we do system monitoring and troubleshooting, basically SQL Skills on a retainer. And then conferences, the PASS Summit, SQL Intersection, which if you don't want to go out to Seattle this year for the PASS Summit, or you live closer to the Las Vegas area, we do have SQL Intersection there this year as well. And that kind of the takeaway from the slide is becoming a SQL Skills Insider. You can go to sqlskills.com/insider. You sign up. It's not a markety, spammy type newsletter. Paul sends out a bi-monthly newsletter chock full of kind of cool little tidbits, what's going on with SQL Skills, and there's always a SQL Skills Insider video, which is anywhere from 3 to maybe 8 minutes with a kind of cool how-to topic. So definitely worthwhile becoming an insider. I mentioned our immersion events. We have Chicago and Bellevue left this year. Lots of training opportunities. You can go to sqlskills.com/training to learn more about all of our sessions. So who am I? I'm a principal consultant with SQL Skills. You can email me at tim@sqlskills.com. I blog at SQL Skills, and then my personal blog, which I haven't really blogged much at either one lately. And then occasionally I get on Twitter. The kind of cool takeaway thing about me is I'm into electronics, aquaponics, and I farm chickens, cows, goats, and tilapia. I mentioned Pluralsight. If you'll email Paul at sqlskills.com and in the subject line put user group Pluralsight Code, Paul will send you a code. It's good for 30 days of all SQL Skills content, which is over 144 hours. And it's a no catch, no credit card required. Just plug the code in, provide an email address for your account, and then start training. So what is the topic today? What are we going to cover? So with understanding SQL Server backups and restores, we're going to discuss the various backup types and things that you need to know, such as service level agreements and why they matter, which backup type is correct for you, how to know that your backups are valid, and then I'm going to share an approach for backing up those very large databases. We're going to talk about how to restore your backups, which is really what this session is about. We're going to talk about having a restore strategy, performing point-in-time restores, and performing a piecemeal restore, which is really kind of cool. And then lastly, we're going to talk about how you need to have a plan, how there has to be a solid restore strategy. Notice I haven't said a backup strategy, a restore strategy, and then having a proven disaster recovery plan. So what are the backup types? So we have a lot of options. I used to say it's a backup buffet. You get which is the right solution for you. So you can do a full backup, a partial, a differential, file group, a file, a log, and then there's this thing called copy only, which here's where I usually mention what copy only is if you're doing a full weekly and a daily differential, you really need to be in the habit of any ad hoc backups that you make using with copy only, because otherwise if you make another full backup, it's going to reset the differential bitmap, and then every differential after that is going to belong to that full backup. If you use with copy only, it does not reset the differential bitmap, so it's not going to mess up your restores chain when later that week, if you have to restore or someone else on your team and they go to the most recent full, which was your scheduled Sunday night full backup, and then they try to apply the most recent differential to find out that differential belonged to this one-off ad hoc backup that you made, that most likely you no longer have. So get in a habit if you're doing differentials using with copy only. So with this, some combination of the above is usually warranted to meet your service level agreements. And for the most of us, doing a weekly full, a daily differential, and then log backups throughout the day is the standard that we see. Or daily fulls and then transaction logs for those mission critical OLTP databases that need point-in-time recovery. However, in the real world, I find critical databases all the time in simple recovery, and so we have to correct that for our clients. So I mentioned a good approach for a very large database. So what is a very large database? Well, it's subjective. It's one of those it depends kind of thing, but for the most part, any database that's hundreds and hundreds of gigabytes could be considered a very large database. I usually don't start looking at partitioning and things for maintenance until I get into the 500 to terabyte size. But if you have those databases and you know they're going to grow to that enormous, very large database size, what are some options that you can do to help with your maintenance operations? And one of the maintenance operations that we do is backups. Well, you can split the data into multiple file groups. And this is very conducive to data that is date-driven. So you can create yearly file groups and place 2011's data in a 2011 file group, 2012 in a 2012 file group, and so forth. You can use partition views to then view the data. You can use a sliding window partition, which is really kind of cool. So you can check in and check out various file groups. But why is this so beneficial for backup and recovery? Well, this allows for a partial restore, meaning that I can restore the active partitions and file groups more quickly. So if my older data that's never changing is in read-only file groups, I can bring on the active data, restoring with partial, and then restore the older archive data at a later time. So I can get the more critical data online much more quickly. And I have a demo of this that I'll show you in a few minutes. So transactions, you have to perform a restore. Now, what are the actions that you need to take? What do you do? Well, in all cases, if this is a production database and you have access to it and you're having to restore over for some reason, you want to go ahead and perform a tail log backup, if you can. And I have a YouTube video where I'm performing a hack attack showing kind of in the worst case scenario how to recover the tail end of a transaction log. And so you can go to timradney.com/tail log restore and it will redirect you to that video. Or stay tuned and I'll demonstrate it in a few minutes. So if you can take the tail end of the log backup, great. What's next? You need to go ahead and restore the last known good full backup. So you restore the full and then your differentials if you have them. And then you start restoring your transaction logs. So this would be if you have differentials, the logs since the differential or the logs since your last known good full backup. And then lastly, you want to restore the tail end of the log that you just took. So through this process, if you haven't performed it, you're not used to going through these steps and restoring with recovery and stepping through these log backups, you need to practice. Because the time to learn this and do it for the first time is not at 2 a.m. in production when everybody's waiting on you or looking at you to perform this action. This is stuff that you should be able to do in your sleep, be 100% comfortable with, and also 100% comfortable that your backup strategy that you have in place meets your recovery strategy and that you're comfortable to know that the backups are good and that you have the skill set and the documentation to go through and perform those restores with ease. So it's having that plan. Test that your backups can restore. So this is having a restore validation process in place. Hopefully most of you or all of you have some process that's already in place where on a weekly or maybe monthly basis you're going through and restoring your production databases to a dedicated instance. And this is restoring, it's testing your recovery plan, it's testing that your backups are good. Then it's also very good for auditors, examiners, and regulators to know that you're regularly testing your backups. This data is also stored in MSDB for every restore that you make. So you can go back and look and see how long are these restores taking. Because I talked about service level agreements. If you have a mission critical system that you need to be able to restore from scratch within 4 hours, and you're testing the restores every week or every month, and this database has grown to a significant size to where you can't recover it within those 4 hours, then you can no longer meet that SLA. And that's something that you need to raise up and lift up to management and state either we need to have a larger window for the SLA or we need to start looking at a high availability solution such as log shipping with a load delay, availability groups, things like that to help mitigate the risk of particular downtime. But then it gets into what are you mitigating against? Are you building an HA solution for if a server fails, or are you building an HA solution to help prevent in case of an oops with the data? If somebody ran an update statement without a where clause, you turned all the last names to Smith. An HA solution, it's still going to be Smith in that secondary. So for that, a load delay or log shipping with a load delay is your best friend, because now you can restore with a stop at before that transaction went and be back online much more quickly than having to restore from a full, your differential, and your logs. So that's kind of outside of the backup and restore, but it's something to be thinking about because it's still related to recovery. So have a proven disaster recovery plan. That means if something were to happen to your data center, what would you do? Most people, when I ask in a room and I'll kind of point somebody out and say, okay, your data center's gone, how do you recover? Well, we recover to another server. Well, where does that server exist? Well, we'd have to order it. Well, then you failed. At that point, can you buy all the equipment and stand up another data center and meet your customers' SLAs? Probably not. So it's knowing where you're going to restore to and then going through that plan. So you recover the user databases. Can the application then point to that new server and connect? Well, did you restore master to get the users and permissions back? No. well then the applications can't connect. So these are the things that you have to test. Just being able to restore the user databases isn't enough. You have to be able to restore the users, the permissions. You need to be able to get back all your jobs, ETL processes. I mean, it's a whole ecosystem. Are there firewalls involved? I mean, that kind of stuff. And if your organization isn't at that level, then please do yourself a favor and have an up-to-date resume. Because if something happens and your company can't recover and you're out of a job, you don't want to waste 2 or 3 days having to build a resume and get back out there and look. So the stuff's real. I mean, it happens. Like Rob said, what's going on in Louisiana right now with all the flooding? How many companies don't have their data somewhere else where they can still be up and running in the cloud, taking orders and things with just a delayed ship date? That type of stuff. I mean, it's sad. It happens. So you and your company need to plan for it, and you personally need to have your plan B. And so by testing those disaster recovery plans, testing them frequently, you can find these gaps, where there may be a host file on a server or a firewall rule, things like that. And then the user objects, the users and permissions, you can script those out. Microsoft has a SP_help_rev_login stored procedure that can script out the users and permissions. You put that into a file, store it where you store your backups, and then if you have to recover to another server, you restore your user databases, run that script, it creates your users and permissions, sync the SIDs, and then at least people can connect. Then you can worry about restoring MSDB. And then know your facts. Know how long restores take. Having that dedicated restore validation server helps drastically. What you don't want to happen is the mission critical half a terabyte database be down or something happen, you're having to restore it from backup, and a C-level executive asks you, well, how long is this going to take? And you say, I don't know. Those are what we call career limiting moves. If you were able to say, well, hold on, let me check, and you go and you query your restore validation server and say, well, the last 18 times that we've done this, it took on average 2 hours and 18 minutes. That's a number. What they don't necessarily have to know is that you're restoring that on a 2 vCPU, 8 gig of RAM with tier 3 storage, and you're restoring on production with 16 physical CPUs, 256 gig of RAM, and solid state storage. That way in reality in production it should take 15 minutes, but in your validation server it took 2 hours. Well, this way you have a little bit of wiggle room. If something happened, a log was out of sync or differential belonged to a different full, and you have to punt and redo another time, it gives you some breathing room. If everything went great, then you can tell that C-level exec, hey, this went much faster in production. It only took 18 minutes. We're back up. I see user connections coming in. You look like a hero, and everything's good. So you want to know how long these restores take. So if you're ever questioned when you're having to do it in production, or to also query against what your SLAs are, you know what you're dealing with. So with that, the PowerPoint is really done. We're going to go into demos. When we come back, I have a recap, and then I say a thank you. So in reality, we're done with PowerPoint. So let me find my virtual machine. And this is the backup 2. We'll go into backup 1. And we're going to step through a whole lot of different demos. So I'm going to start by restoring a database called backup sample. And that way I know what I'm dealing with. I'm going back to a known state. And I'm going to clear my backup history. Now this is something else that you need to be aware of. If you're using a database maintenance plan, then it has an option in there to choose how much history to keep. If you're using a third-party tool, most of them include a job or a process to prune the backup history. But if you've kind of created your own, then your backup history, it's not being purged automatically for you. So MSDB will keep up with all backup and restore history until you purge it. And you purge it by executing sp_delete_backup history and then passing a date. And the date parameter that you pass, it deletes all history prior to that date. So I'm telling it delete everything that happened before tomorrow. So basically delete everything. In reality, you could take this job and make this be a minus 30, and you only keep 30 days worth of backup history. All right, so I cleared my history, and what I want to show you is the sales order ID from the sales table. Our max sales order ID is 75123. So I'm going to go ahead and kick off a full backup and then a transaction log backup. And what I'm going to do is I'm going to step through and I'm going to simulate production. So in the real world, you're doing transaction log backups every, say, 15 minutes. It could be 5 minutes, could be every hour, whatever's the SLA for your organization. So we're going to pretend it's every 15 minutes. So 15 minutes has occurred, we inserted 75150, and we do a log backup. We're going to insert another transaction, another log backup, inserting another transaction, 75250, and a log backup. So we'll insert those, and then we'll take a look at the sales order ID table, and we see that we've added 3 additional transactions, and we've done a total of 4 log backups. So in production, this just happened. Transactions have been occurring. We have a failure right now. So we need to restore from our full, and we want to get back to right now after 75250 was inserted. So what would our restore chain look like? What would our restore script? What do we need to restore? Is it the most recent full and the most recent transaction log? Or do we have to restore the full in every transaction log since the full? Well, we have to restore the full in all logs since that full. But that could take some time to write that script and the locations that we wrote out to, because we have to specify restore database backup sample from disk equals and the path and with replace and so forth. But what if you had a script that you could run that would generate this restore script for you? Well, I have just that. Since all the data is stored in MSDB, I can execute a script and it will come back and generate my restore script. Just show me I'm restoring my base, my full, and then each log backup, and then finally restore database backup sample with recovery. So that's pretty cool. So if you had something like this and you could incorporate it into your backup script or your backup job, then in reality you could create your restore script after every backup was taken and store that script into a folder or the same path as your backup files are going. So in the event that you have to recover, you have the most recent restore script since the last backup. So that's a pretty cool thing to have. So we'll go ahead and close this. But what if you're doing differentials? How would that change things? So we're going to, again, restore to a known state. We're going to clear that backup history again. We're going to go ahead and do a full backup and a log backup. And just like before, we're going to insert transactions. So we're going to insert 75150, and we're going to do a log backup. We're going to insert 75200, and we're doing a differential backup this time. So we're specifying with differential. Inserting a third record, 75400, and then another log backup, a fourth record, 75500, and finally a log backup. So what does our restore process look like now? Or what would it look like? So we did a full, a log, a differential, and then a log and a log. Well, a differential would contain all the transactions since the most recent full backup. So we could skip that log. So it should be a full, the differential, and then log log. So let's take a look with our restore script. And we see that we have our full, our differential, and then a log, and then restore with recovery. So pretty cool so far. I mentioned about a piecemeal restore. So we're going to switch over to another database, and this one's going to be backup file group sample. So we're restoring, we'll refresh the backup file group sample. We'll take a look at some properties, and we'll see that we have a single file in a data file and log file, and we just have a primary file group. So we're going to go through and do a few things here. I'm going to show you that we have 121,000 records and that our data ranges from 2009 through 2012. So I really should go and update these dates to be current data. Let's go ahead and do a full backup in case I blow something up. And I'm going to partition my data by creating 3 additional file groups. And then I'm going to run a partition script. Actually, this is going to create the additional files. And then I'm going to run a partition script to partition my data. So now we'll go back, we'll refresh, and we'll take a look at the database, and we see that we have additional files. So we have a 2009, 10, and 11, and we have 6 meg worth of data in 2009, 2 meg in 2010, and 3 meg in 2011. Then we have additional file groups with a file per file group. All right, so I'm going to go ahead and kick off a backup. I'm going to do a full just in case I blow something up. And then here, when you have partition data, you can specify with file group. So we're going to backup database, backup file group sample, and my primary file group, I'm going to back up the 2009, 2010, and 2011. So we'll back these up. We're going to take a look and just make sure that we still have the same 121,000 records, so I have not done anything funny here. And now we're going to bring on, or we're going to restore just the primary file group. So we do this by specifying restore database, backup file group sample, file group equals primary. This could just as easily say, if we've already restored the primary, it could be file group 2010, 2011, or so forth. So restore database, backup file group sample, file group equals primary from disk, and then this is the only time that you'll use with partial, is when you're restoring the primary file group. So restore with partial, we're going to choose recovery because we want to be able to access this data immediately, and then we're going to replace the database that exists. So we execute, and we have now just brought online 1,016 pages for this database. So let's refresh and take a look and see what the database looks like. So it looks like it's online, that we can, I mean, it's not in recovery, it's not pending, it's a recovered database. So if we take a look at the sysdatabase files for this database, we see that the primary file group, the log are both online, but 2009, 10, and 11 are in a recovery pending state. So that's pretty cool. So the primary file group contained our 2012 and above data. So if we query the database for 2012 and above, we'll get 50,000 records. If we try to query a date range that's outside of the primary file group, we're going to get an error. So one of the partitions of the index for table DBO cells gives us the partition ID, resides on a file group 2009 that cannot be accessed because it is offline, restoring, or defunct. This may limit the query results. Well, it limited because we have none. So let's restore the 2009 file group by specifying file group equals 2009. We take a look at the sysdatabase files, and we now see that 2009 is online. So if we query between 2009 a data set, we get 43,000 records. But if we go back and we query we're greater than a 2009, it's going to fail when it gets to the file group 2010. Now notice before it said could limit the results. So we go and look at our results, and we have the 2009 data, but it failed once we hit the 2010. So with 2009 and 2012, we can query both if we specify we're between or in or some value that limits it to the 2009 data and 2012 data. So now we have 94,000 results. So we'll go ahead and bring on 2010 and 11. We'll view the sysdatabase files, and everything's online, and we can query all data in the database. So all 121,000 records are there. So how cool is that? That you have a database that you can bring portions of it back online. And with Enterprise Edition, I'm using Developer, this is an online operation. With Standard Edition, it would be an offline operation while I'm doing the restores of the individual file groups. But Enterprise, that's an online operation. So how cool would it be in production with your multi-terabyte databases, if your active data that people are accessing the most, you could bring online in minutes versus the hour or multi-hours that it would take to restore the multi-terabyte database. So you can restore end-user functionality much more quickly if you can partition that older archive data into secondary file groups that you can restore at a later time. So pretty cool. So I mentioned about a tail log. So I'm going to go ahead, and this is a really cool demo. We're going to restore the database. We're using the restore script from a previous demo. So we'll go ahead and take a look at our top cells. So our top one is 75250. So I'm going to insert another transaction. This one is 5 nines, because we all strive for that 99.999% uptime. So we insert the transaction. We'll take a look at the top two sales order IDs. So we got the 75250 and the 5 nines. So I'm going to set my database offline. So we'll refresh, and we see that backup sample is offline. I'm going to go to my SQL data folder, the backup sample data file, and I'm going to delete it. So your file can't become too much more corrupt than not existing. So if we try to bring the database back online, who thinks we can do this? Who thinks the database will come back online? Well, of course it can't. There's no MDF file for it to attach. But we refresh the database and we're in a recovery pending state. You'll remember this from the piecemeal restore. So recovery pending is a unique state. So if we try to back up our database, or our transaction log, so we're going to do it with just backup log, database name, to disk equals. And it's going to fail because it's trying to write a checkpoint. And it can't do so because the data file doesn't exist. So we get a nasty little error message. But if we back up with no truncate, we just backed up the tail end of the transaction log. So we're going to use the same restore script above, but we're including our tail log backup that we just made. We'll take a look, and we have our two sales order IDs. So that's really cool. But what if we need to do this on a server that, the real world example of when this can happen? You ask for additional storage, your SAN admin says I have to provision a new LUN or add more storage, and you get a call within a few minutes and there's been an oops situation where the SAN admin formatted the wrong LUN. And they formatted your data LUN, so that took out your master data file, model, MSDB, your user data files, so your instance is gone. So you can't restore to the same instance in this case. Your transaction log LUN is there and is intact, so you can get the LDF file. Well, since I have the LDF file, can I attach the LDF, the log file, to another database and still be able to back up the tail end of the transaction log? Because in this case, I was able to do it without an MDF, but my instance knew the database already existed. So let's go to another instance. So this is another server. We refresh databases, and there's no backup sample database. So we're going to create a database called backup sample. And I don't know why it's thinking so hard. Should be pretty quick. Let's go to another query window. Maybe something's wrong with this instance. All right. So we have our backup sample database. So we're going to go ahead and we're going to alter it and set it offline. And because I back up my databases to a network share or a backup deduplication device, somewhere other than the server itself, I have access to all my previous backups, and I have access to that log file. So what I'm going to do now that I've set this database offline, and we'll refresh and we see that it's offline, I'm going to go to my SQL data folder. I'm going to go ahead and delete the backup sample data file. I'm going to go into my backup location, and I'm going to grab that log file. And I'm going to overwrite the log that was created when I created the empty database. So I've now replaced the log file with my production log file, and I've deleted the data file. So if I go and try to set the database back online, I get the same message as before because there's no data file. But I refresh my database, and now I get the recovery pending state. So I'm going to back up the log just like before. So now we take the copy of the backup files and the tail log that we just made. We restore those to a server that's never seen this database before. And we have the 5.9's data transaction. So what you just witnessed was taking a transaction log file from one database, attaching it to another database, and still backing up the tail end of the transaction log. That is very impressive to be able to do this in production if the situation ever comes up. This is the difference between zero data loss and a few minutes of extra downtime versus your organization having to announce to the world that they lost consumer data. You know, we all accept, you know, a minimal amount of data loss, you know, because your transaction log intervals 5 minutes, 10 minutes, or 15 minutes. So you've accepted up to that amount of data loss, but it's not necessary that you have to lose that data. I mean, if you have access to the transaction log and it's healthy, you can still back up those transactions. So this is a very cool thing. You know, I like to joke and say that being able to do this is a promotion, a pay raise, an extra week of vacation, I mean, ransom, I mean, whatever you want to call it. But this is, you know, a very cool thing to know how to do and to know that it exists, that it can be done. So I hope you never have to use this in production, but for those of you who are attending, you know, I'm going to make these scripts available and even the demos. So you can go and reproduce all of this. Practice this. I mean, this is Developer Edition, which is now free. I mean, go download 2016 Developer Edition and play with this and get familiar with it and practice. And you just hope you never have to use it in production. So let's go and see what we have left. What else we can do? So that's the tail log. So we'll close there. So we now have SQL Server encryption that's native built into SQL Server. And with encryption, this is really kind of, you know, cool with the backup encryption. You know, we've had TDE and we've had third-party products that we can encrypt the data within the database. And with TDE, it's great because then your backups are encrypted, but not everybody's using TDE, and TDE is kind of, you know, costly from operational to use just for backup encryption. And so with backup encryption, we've had to use third-party products, or we have to back up the file and then encrypt that file. But now you can do it natively from within SQL Server. And by doing this means that you're protecting your backup files, because right now, if you're backing up to a network share, anyone that has access to that network share, if those backups are unencrypted, can take them, install them, or restore them to a developer edition where they're a sysadmin and have access to all the data. If you're backing up to a deduplication backup device, you know, the administrators of that system can take any of that data, restore it. So it's kind of a scary thought. You know, yeah, we trust all these people, but you know, your organization, if you have PCI, PII, HIPAA, you know, type data, you really need to consider upgrading to a version of SQL that supports backup encryption, or using a third-party product to encrypt those backup files. So how do you use the native built-in encryption for backups with SQL Server? So first we have to have a master key. So I'm going to check and make sure that this instance is clean, I don't have a master key or certificate, so I do not. So we're just going to create a master key. So you create master key encryption by password, and I'm going to call it SQL Skills @ Very, very secure. That's encrypted by it. Okay, so I have to run those deletes separately. All right, so here we go. We're going to create our master key, And then you need a server certificate. So we're going to create a server certificate, SQL Skills Encrypt Cert. You can give it a description, a subject, so I'm calling it the SQL Skills Backup Encryption Certificate. So we'll create this. And then before you can start using the encryption certificate, you have to back it up and encrypt it. So this is so that you have a copy of it, because otherwise, if you created your certificate and started encrypting all of your backups and something happened to that instance, then you can't restore that certificate to another server, so you have some really big files that are encrypted that cannot be decrypted. So it's a very bad day. So thank you to Microsoft for putting this check in. That if I try to use the certificate, it would tell me I can't until I back it up. And then you have to encrypt it when you back it up. So we're going to provide a password. It needs to be a complex password. So I'm using a complex password. And now we can begin backing up with the certificate. So, backup master key. So we backed up the key. Now I have to back up the certificate. So we do the same. And now we can start using that certificate. So backup database, backup sample to disk, and I'm going to back it up using with compression in encryption. With compression, the encryption algorithm that we're going to use is the AES 256, and then you specify which certificate. So if you have multiple databases and say they're supporting different applications, you could have a different encryption key or encryption server certificate per database or per application. You can make it as complex as you want. In this case, I'm just using the one certificate, SQL Skills Encrypt Cert. And then to show you that you can still get the benefits of server-side compression with encryption, we're going to back up the database with no encryption and no compression. So let's go ahead and back these up. And then let's take a look at our C SQL Backup folder. And we see that with compression and encryption, it's 4.5 megabytes. With no compression, it's 15 megabytes. So we get a reduction by 2/3 with using compression while using encryption. So that's pretty nice. Years and years ago, when you would use encryption, then everything would be randomized and you'd get no compression algorithm built in. So I'm glad to see that we still get the benefits of compression while using native encryption. So how do you restore an encrypted database? Well, since our encryption certificate already exists on this server, or this instance, it's restore database, database name from disk with replace. There's nothing special that we have to specify. So we can restore the encrypted database. What if I drop the certificate and then I try to run the same restore? It's going to fail, stating that the server certificate with thumbprint, and it gives us the thumbprint ID, does not exist. Well, before we just created the certificate specifying the name and we gave it a description. So what if we recreate it using that? And we try to restore the database. Well, that server certificate does not have the exact same thumbprint as the previous one did. So we can't do that. You have to restore or create it from the backup file. So we have to create the certificate from file with the private key. So that encryption key that we backed up. And we have to decrypt it with the password that we used to encrypt it when we backed up the certificate. So this is very important. You're getting into key management now. If you back up the certificate and you create some random password that you forget, then you can't restore or create that certificate from the backup that you made. It's as good as not having the backup at all. So it's encrypted. So you need to have a key management process in place. The Azure Key Vault is a great place. There's third-party tools. There's also just typing this stuff out, storing it in a file, putting it in under lock and key. Break glass here to get access to it, type thing. So work with your information security department in what is your enterprise process for key management, because they're already dealing with server-side certificates and everything else where they're dealing with this type stuff. So they probably already have a tool that you can use to check this stuff into. So make sure that you maintain this. So we're going to create the certificate, and now we can restore from backup. So what if this is on a whole nother server? This instance is gone, we need to restore to another server. It's going to be the exact same process. So we come over here, we take a look at the encryption. We're going to make sure that I go ahead and clean things up because I've done this demo before. So I can't drop because it doesn't exist and the master key doesn't exist. All right, so we're going to create a new master key. The master key can be anything you want. On the old server, it was SQL skills @ This one we're using new SQL skills. So if I try to restore the encrypted backup without restoring the certificate, it's going to fail. So we create, because that certificate with a thumbprint, so we're going to create it from file with that complex password. And now we can restore the database. So it's very simple. So if you have servers that you're regularly restoring over to, you can create those certificates ahead of time so that your processes can automatically restore, or whatever process you have in place to do restore validations can still do those restore validations of encrypted backups. In this particular instance, it's just struggling due to whatever it's trying to run in the background. All right, so we were able to restore the encrypted backup. So that's all we have on that particular server.
Hey, Tim?
Yes, sir.
We have one question here. They're asking, how does the backup encryption impact the effectiveness of a backup appliance with deduplication?
Well, with deduplication, again, it's going to be that data is going to be randomized, so your deduplication ratio will go down. But you have to look at the overall purpose. What are you trying to do? So, do you want to encrypt all your user databases? Maybe that's not critical because there's not really PCI HIPAA type data in there, and you have other controls in place where your deduplication device is a CIFS share and only the DBAs have access to it in the backup deduplication device admin. So maybe some of the risks are already mitigated, but when it comes to PCI or HIPAA, you're not concerned about the deduplication of the data, you're concerned about the protection of the data. So in that case, yeah, you're not going to be able to dedupe the encrypted backup, but you're still going to get compression. So from the space savings, it's going to help somewhat, but you're not going to be able to dedupe that data.
Thank you.
All right, we're going to try this demo, see if it'll work. I'm going to go ahead and change the location. So with SQL Server, I believe it was 2012 cumulative, or like Service Pack 1 cumulative update 6, or some randomness like that, backup to URL was introduced. A lot of people think this is a 2014 feature, but it was actually released in that cumulative update with 2012. And what it enabled us to do is, when you'd go in to back up a database, a new option appeared where you could back up to URL, and that was kind of new to us. And I like to joke and say it's kind of like the Ford with the Model T. You can have the Model T in whatever color you want, so long as it's black. You can back up to whatever URL that you want, so long as it's Azure, which for me works fine. Azure storage is very cheap. So your backup string, your backup script doesn't really have to change a whole lot. Instead of backup to disk equals, it's backup to URL equals, and then you specify your blob storage. So of course mine is sqlskills.blob.core.windows, blah blah blah. And you can't overwrite a file, so it has to be a new file name each time. And then you specify with credentials. So this is the credentials that you use to connect to Azure. And I think it's under server object. Let's see, where do we go for credentials under security? And then we're going to use the Azure backup one, and then I have a different one that I use for SQL intersection demos. So we'll see how well this will work. Backup database, backup sample to my Azure blob storage. As long as I haven't deleted that storage, it should work. We're using stats equals 1. So we'll initialize, try to connect, and we'll see how well this will go. So while that's running, I'll go ahead and load up my next demo, and I know we're coming up on time. So we see that 100% process, so we just backed up to an Azure backup 23 seconds for this 100 meg database. And then with the restore, I won't spend the time because it takes a little bit longer to do the restore, but it's the same process. Restore database name from URL with credential. So you have to connect again to be able to pull your file back down. So it's really simple to do, and this is a really effective way of getting your backup files to a third-party location. So if you need that offsite backup. Now, would I recommend this as the sole place to put your backup files? No. Would I say backup to Azure by default? I would say no. Reason being is I would rather restore from a local backup that would be much more, much faster than relying on my network bandwidth to do my restores. Because what happens if we had a disaster, had a major power outage or something, the generator and backups didn't kick in, SAN went down, we have our infrastructure back up, but I have some suspect databases because the way they crashed, you couldn't go through crash recovery coming back up, and they're suspect, and I need to restore from backup. But yet our core internet providers are still down due to the same kind of outage. I can now no longer restore my databases to get my customer functionality back for those local because I'm having to rely on offsite backups. So what I would use is I would still back up local, and then I would use like, I think it's AZ copy, to then copy those backup files to Azure storage to have the offsite, and then if I wanted to leverage Azure for DR, then I could attach that blob storage to an Azure virtual machine and go ahead and set up a kind of a log shipping process where I have a database and it's looping through restoring from that location to keep my databases warm in the event I had to fail over to it. So there's lots of options built in, with Azure virtual machines and Azure storage, backup to Azure. So it's something you could definitely play with. It's a cool feature. I'm sure some use it for production, but for me, I still want that local copy. So my last demo I want to do, this is a fairly new demo. So I want to go ahead and see if I can step through it and it actually work. So we're going to take a look. This table exists. So right now I have no data in my point in time table. So if I restore, how was it in the? All right, so the backup switched to the right database, so the point in time table doesn't exist. So we're going to use master. I'm going to restore my entire database with my full transaction log. And then we'll switch to my backup sample database and then look at point in time. So from this transaction log, on March 24th, every 30 seconds a transaction was written to the table. So let's say from this transaction log, I want to stop at a particular point in time. So right here is where something bad happened. So I want to stop at this moment. So I can take that time, and it's already placed in here. So this is where we say point in time restore. Most of us are just talking about restoring to your most recent transaction log. So restoring this whole thing and being at 3:24 at 2:11:56 in the afternoon. And that'd be the point in time. But you can truly get to a particular point in time, and this is where Azure SQL Database kind of kicks in. You get to the truly point in time. To do it with on-premise, we have to use with stop at. And so I can stop at a particular point within the transaction log and not have to restore the entire log. So if we restore this, use this statement, we're going to stop at 9:26:657. And so we stopped at that particular time. So the 5 transactions after that, we did not restore. So this is pretty cool. If that, you're in that 15-minute window of transaction log backup, and somebody ran that update statement without the where clause, and they knew the exact time that they ran it, then you could specify to stop at that particular time within the log. So this is truly that point in time restore. So if you pretty neat. So with that, we are pretty well done with the demos. We went through a lot of things, and we talked about know your backup types. So you certainly want to be in full recovery if you have that OLTP database that you need to be performing transaction log backups on. You want to make sure that you have the right ones to meet your customers' SLAs, and then knowing how to recover. So we just went through a lot of different scenarios, from restoring a full, differential, transaction logs. You saw a piecemeal restore. You saw a hack attach. You saw a stop at. So you can get down to where within the transaction log. You saw restoring to Azure, using encryption. So a lot of different ways of backing up data and recovering from that data. And so whatever process your organization is using, you want to make sure that you know how to recover from each one of those scenarios. So you want to have that restore strategy. So not just a backup strategy. Your restore strategy will dictate the type of backups that you take. And then knowing how long those restores will take is very important. That way you can meet those service level agreements. And then knowing how to perform those point-in-time restores that we just went through. And then having that plan. Like I said, the first time you perform a restore should not be in production. So test these things out. And know that you have that solid backup strategy that meets the requirements so that you can sleep at night, you have that comfort that you can maintain your job, and that your organization can sustain that, that outage, that y'all can survive. And then having that proven disaster recovery plan in place, so when those events happen, your data center becomes a smoking hole, or it gets flooded, a hurricane, tornado, earthquake, those things happen, that you can recover. You can stand up in your secondary data center and keep moving along. So what I will do is I'm going to put a copy of this presentation and all the demo scripts and sample databases out on my website. So it will be listed under the Data Architecture 817, and you can find that at timradney.com/presentations. So with that, I want to thank you all for attending and being a member of the Data Architecture virtual chapter, being a member of PASS, and for joining us this afternoon. And like Rob said, if you have any questions, I know there was one throughout the session, but any questions that you have related to SQL Server Backup and Recovery, HADR, feel free to email me at tim@sqlskills.com, and I'll try to respond to you as quickly as possible.
Tim, we have one question here. It's about your book, and they're just asking, does your book cover these topics you presented today?
Yes, it doesn't cover with stop at, but all the full differential, T-log, hack attach, all the methodologies, it's all there. So the session then birthed the book.
Okay. And the follow-up to that question is, does it include any sample DR plans in your book? Or
not really, but if that might be something for the 2016 to include various scenarios.
It's a great thought, like a template maybe. I don't know, just throwing things out.
Yeah, I mean, definitely covering various scenarios with the technologies that we have. I mean, honestly, now that it's been a while since I've written the book, but I want to say I'm looking for I usually keep a copy of it like handy. Let me grab one off my bookshelf. I know I cover like very common backup strategies. I don't know if that would actually include it's common restore strategies, but not really DR plans. So that's whoever asked that question, thank you. I will definitely, I've already made a note to consider adding that for the 2016 version.
So thank you. I mean, it's some of the demos were really awesome, like where you restored the log to another database. I mean, backed up the log from another database. Really cool stuff today. And for the chapter, I want to thank you for coming on, and thank everybody in the chapter for being here today. And so we're going to have another meeting next month, and please sign up for that. I'll send an email out, and I hope everybody has a great day, and keep prayers going to all the people here that lost a lot of stuff. Thank you, Tim, again, and I hope everyone has a great evening. Bye.
Thank you.